Right. Okay, students. So in the whole geometry section, today I am going to discuss grade 10 geometry section, right? Grade 10 geometry section, I include some of the additional grade 9 also, right? Okay, so we can start the concept of geometry from the axioms, okay? Concept of geometry from the axioms, right? You know these axioms, students. What is the first one? Take the first one. Quantities which are equal to the same quantity are equal. Okay. For example, A equal to B and B equal to C. What is the conclusion? One more time. A equal to B, B equal to C. Then what is the conclusion? Yes, students, B is common to these, both the equation. Now, A equal to C. Students, the axioms are important to build up theorems. Okay. So for the theorems, axioms are important, right? So that is the reason I start from these theorem axioms, right? This is the first axiom: quantity which are equal to the same quantity are equal, right? Okay, that is done. The second one, quantity which are obtained by adding equal quantities to equal quantities are equal. For example, if A equal to B, I add equal quantities to the equal quantity, A plus C, B plus C. Here I add equal quantities to the equal one. Now what happened? Both are equal. This is the second axiom. Okay. The numbers are not important. Axiom 1, axiom 2, axiom 3. That is not important. If you mention normally axiom, it's enough. Okay. Right. Right. Next. Quantities which are obtained by subtracting equal quantities from equal quantities are equal. If A equal to B, I subtract C in left side and right side. Here, what happened? Both are equal. Okay. Right. First axiom, second axiom, third axiom. It is okay. Right. Now, next one. Sorry. Next one. Products which are equal quantity multiplied by equals are equal. That means, students, if A equal to B, I multiply A by C, B by C. Then both are equal. Okay. If A equal to B, then times C for A times C for B are equal. The quotients which are equal quantities divided by non-zero equal are equal. Non-zero means this is C is not equal to 0, right? You can divide any other number, right? So if A equal to B, then A divided by C equal to B divided by C, right? Okay, these are the basic things about axioms. Okay, right. Now we can go to the theorem, students. The first theorem. What is the first theorem? That Euclid says the sum of the adjacent angles formed by a straight line meeting another is equal to how much? The sum of the adjacent angles formed by a straight line meeting another straight line is 2 right angles. Okay. Here, students, they mention the adjacent angle. So we can take this one and this one are adjacent angle. Okay. These two adjacent angles are 180. Okay. These two adjacent angles are lie on a straight line. So if you mention it x, this one is y, x plus y is 180. Okay. X plus y is 180. One more thing, students. Here, this is, we can take this one A. In this Y, B, C, D are there. So the finally, A plus B plus C plus D equal to 180 degrees. Sum of angle on a straight line is 180 degrees. Okay, that is the basic one, right? Okay. Next theorem. The vertically opposite angles formed by the intersection of two straight lines are equal. Time. The vertical opposite angles formed by the intersection of two straight lines are equal. Here, that means this angle equal to this angle, AOC equal to DOB. Then this angle, AOD equal to BOC. Okay, right? How to prove this vertically opposite angles equal theorem? How to prove? How to prove that? Right, I mentioned A, B, C, B. How to mention? How to prove that A is equal to C, students? So the provement, you can use the earlier provement, earlier theorems and axioms. Okay, students, our first theorem is sum of the angle on a straight line is 180 degrees. So student, A plus B equal to 180. Same A plus D equal to 108. Right. What can you say about these two equations? This is the first equation, second equation. Then this sum is 180, this sum also 180. So students, A plus B equal to A plus D. What is the reason, students? What is the reason? Let's see. Okay. Now A plus B equal to A plus D. I subtract A in left side and right side. So B equal to A. Here also we can use that axiom. I subtract A in left side and right side. So axiom, then B equal to, sorry, A plus, B is equal to D. Right? B is equal to D. Students, have you understood? Yeah. What is the basic provement for this theorem? Vertically opposite angles are equal. Shall I explain one more time? All of you listen. Here, students, we can take A, B, C, D. We can take A plus B is equal to 180 degrees, sum of angle on a straight line. A plus D is equal to 180 degrees, sum of angle on a straight line. Both are equal, 180 degrees. We can write A plus B equal to A plus D. Axiom. Same axiom we can apply. A plus B minus A is equal to A plus D minus A. I subtract A in left side and right side. Then we obtain B is equal to D. Here also axiom. What is the reason? I subtract equal quantities from the equal quantity. So we can apply the same thing for the other side also. Right. Sir, if you enable to chat, we can discuss with you. Yes. Okay, you can ask if you have any other doubts, you can ask with chat. Right. 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 Okay, students. Now, students, the theorem. Right. Students, do you know this word transversal? Do you know this word transversal? Okay, students, here, if a straight line is a some straight line. If a straight line meets more than or equal to 2 or more. If a straight line meets 2 or more than straight line, this straight line is called transversal. Okay, this is the basic theorem, students, in grade 9. Okay, right. Okay, students, so that is transversal. When a transversal intersect a pair of parallel lines, okay, when a transversal intersect a pair of parallel lines, the corresponding angles form are equal. The corresponding angles form are equal. Alternate angles form are equal. The sum of the each pair of allied angles form equal to right angle, two right angles. That means, student, corresponding angle. Corresponding angle. Student, check. What are the corresponding angle? This one and this one. Shall I name it as A, B, C, D? A, B, C, D, E, F, G, H. Okay. A and E are corresponding angle. These are two parallel lines, so A equal to E. B and F are corresponding angle. These two lines are parallel, so B is equal to F. C and G are corresponding angle. These two lines are parallel, so C is equal to G. Right? D and H are corresponding angle. These two lines are parallel. D is equal to H. This is corresponding angle. A equal to E, B equal to F, C is equal to B, G is equal to H is equal to D. Right? These are corresponding angle. Students, then alternate angle. Alternate angles. Yes, students. Alternate angles. D and F. D is equal to F. Okay. Then this one, C is equal to E. So alternate angles equal. Corresponding angles equal. One more thing, the sum of pair of allied angles 180 degrees. So what are the allied angles? Allied angles, students. C and F. C plus F 180 degrees. D plus E 180 degrees. Okay. So students, when a transversal intersect a pair of parallel lines, corresponding angles are equal, alternate angles are equal, allied angles, sum of allied angles 180 degrees. Right? Okay. Right. Okay. Congruency cases. Students, the congruence of triangle. Totally, how many congruent, the condition of congruence are there? Totally, 4 conditions, right? Right. What are they? Okay, we will check, right? Right. Students, check the first congruent case. Congruence of triangles. If two sides are and include angle of one triangle are equal, two true side and include angle of another triangle, then the two triangles are congruent according to the case side angle side. Okay, one more time. What is the case, students? Repeat it. Yeah. Mm. Right. Okay. Right. Students, the question is, what are um, the condition, number of conditions are there for congruence of two triangles? Totally, the four conditions. If that satisfy two sides and include angle of a triangle are equal to two sides and include angle of another triangle, then the two triangles are congruent. That is one of the cases. Here, students, you mentioned this one here, this word included angle. The word included angle. So which one is the easiest? This one is also right. Hmm. Right. In this case, students, which one is important, students? The included angle. Included angle, right? 1 minute. Yeah, I want to adjust this bar. How to remove that bar? Here, student, this one of the bar is back here. Wait, 1 minute. Ah, student, how to remove this bar? Okay, check, right? Right, students, listen. If two sides and the included angles of a triangle are equal, right? Um, two sides of the included angle of another triangle. Here, students, the included angle, it is important. Okay, included angle is important for you, right? Here, students, this side equal to this side and this side equal to this side. If that angle meet these two mentioned side equal to the angle formed by the meeting of that mentioned side, then these two triangles are congruent. So that is the reason, students, they mention included angle. The included angle, that word is important, right? Here, students, two sides are equal. These are two triangles, okay? This side equal to this side equal to this side. If, student, this angle equal to this angle, here the condition, two sides equal, then one angle equal, but these are not congruent. Why, students? These are not included angle. So, students, in the congruency condition, you must consider this word included angle. Right. Next. Next one, students. Right. Right. Done. If two angles and the side, right, that is done, students. Okay. If two angles and the side of one triangle are equal to two angles and the corresponding sides of another triangle, then the two triangles are congruent. Okay. Students, here also you have to underline the word corresponding. Okay. Two angles equal. This one equal to this one, and this one equal to this one. But here, student, corresponding, what do you mean the corresponding side? Here, this one is opposite of this single angle. This one also opposite of this single mention angle. Here. Now these two triangles are congruent. In this case, students, these are two triangles. This one equal to this one. This one equal to this one. This side and this side are equal. These are not congruent, students. The reason, not corresponding angle. Here, students, this side located between these two angles. Here, this side is opposite of this double angle. So, not in the corresponding position. So, these are not congruent. So, consider these one, students. Two angles and a side equal to two angle and the corresponding side. Here, opposite of single. Here, also opposite of single. So, these are congruent. Okay, this is the second case. Now, third case. That is easy, students. Three sides of a triangle are equal to three sides of another triangle. Then the two triangles are SSS case. Then this is the one, other one. In a right angle triangle, hypotenuse and a side. You know this hypotenuse, right? This one is hypotenuse, opposite of right angle. Hypotenuse and a side equal to hypotenuse and a side of another triangle. Then these two triangles are congruent. One more time. Hypotenuse and a side of right angle triangle equal to hypotenuse and the side of another right angle triangle, then the two triangles are congruent. Okay, next. Students, we learned the four conditions: side, angle, side, angle, side, side, and in the right angle triangle, hypotenuse side. Right. Okay. Right. Next, students, this is the sum of interior angle of a triangle is 180 degrees. Right? Sum of interior angle of a triangle is 180 degrees. If this A, B, C, then A plus B plus C is 180 degrees. Okay, I'm going to prove this one. Here, we can take this one is A, this one is B, this one is C. Here, one of the construction, I produce that line BC up to D. I produce this line BC to D and draw a line parallel to BA through C. This is the construction line. So, that is indicated by the dotted line. Okay, right? Okay, what is the construction? A line drawn from C is parallel to B, that is CE. Right now, if this A, this one is A, what is the reason, students? Alternate angle. If this B, this one is B, what is the reason? Corresponding angle. Now these three angles are lie on a straight line. Here, A plus B plus C is equal to 180 degree. Reason, sum of angle on a straight line. A plus B plus C is equal to 180 degree. Reason, sum of angle on a straight line. Okay, here sum of angle on a straight line is 180 degree. But here the same angle are interior angle of a triangle. The same three angles are interior angle of a triangle. So the conclusion, sum of interior angle of a triangle is 180 degree. Okay, this is the basic provement of the theorem. Sum of interior angle of a triangle is 180 degree. Okay, right. We can go to the next thing. Students, I revise everything in grade 10. Okay, right. Right. Next, the exterior angle formed. Students, this is a triangle. If you produce a side of a triangle, exterior angle formed. Exterior angle is equal to, here, this exterior angle equal to exterior angle equal to sum of interior opposite angle. What is exterior? This is the exterior angle. Exterior angle is equal to sum of, this is interior angle, sum of interior opposite angle. Okay, right? This is the formal provement for this theorem. The same thing. We can take it as A, this is B, this one is C. If this A, this one is A. If this B, this one is B, right? Now, students, here, what is the sum of, this is exterior angle. This one is exterior angle. How much exterior angle? A plus B. This is interior. The C is interior. Opposite angle. Interior opposite angle, how much? That one also A plus B. So, the exterior angle is equal to sum of interior opposite angle. What is exterior angle is equal to sum of interior opposite angle. One more time, students. This A, this one is A, alternate angle. If this B, this one is B, corresponding angle. The total is A plus B. Here, the sum is A plus B. Both are same. That is the formal theorem of this, formal provement of this theorem. Student, the theorem is the exterior angle formed when a side of the triangle is produced is equal to the sum of the two interior opposite angles. Right, next. Right. Isosceles triangle theorem. What is the theorem? If two sides are equal in a triangle, the angle opposite the sides are equal. That means, students, if these two sides are equal in a triangle, if two sides are equal, opposite of this side is this angle, opposite of this side is this angle. These two angles are equal. Okay, right, students, the formal provement for this theorem. Here, this is a triangle, the given AB equal to AC. In the triangles, ABD, ACD, AB equal to AC. Right? Okay. That is given. Then, students, one of the construction, the angular bisector of BAC meets BC at D. One more time, construction, right? This is construct. Construct the angular bisector of BAC that meets BC at D. That means, students, this angle equal to this angle. So we can mention it. BAD equal to BAD. Uh, and AD is the bisector of BSC. Okay, what is the reason? AD is the bisector of BSC. Now, students, AD equal to AD, right? AD common, right? Common side. So, what can you say about these two triangles? Therefore, triangle ABD concurrent to triangle ACD. Reason? What is the reason, students? Side angle, side. So these two triangles are congruent. So corresponding elements are equal. This angle equal to this angle. Why? Corresponding elements in a congruent triangles are equal. So two angles are equal. Right. That is the formal theorem of this theorem. Right. Formal provement of this theorem. Right. Okay. Next, the converse theorem. The sides opposite equal angles of the triangle are equal. If that two angles are equal, these two angles are equal, opposite sides also equal. The provement, same provement, students. Angular bisector of QP RS PX. Then this angle equal to this angle equal to this angle, this side equal to this side. So these two triangles are congruent, angle, angle, side. Therefore, corresponding elements equal, these two sides are equal. Okay, this is the formal provement of the theorem, right? Yeah. Students, now I just revised the theory. After the theory part, we can do the questions, right? Very important. Here. Check this all condition. Check these all conditions. Right. Check the first statement. What is the first statement? The perpendicular drawn from the apex to the opposite side. Students, have you understood the word apex? The same equal sides meeting point is apex, right? Right, right. Very important thing, student. You can apply this conclusion in the theorem. The perpendicular drawn from the apex to the opposite side. Yeah, like this is an isosceles triangle, right? In only the isosceles. Okay. This one is isosceles triangle. I'm going to draw perpendicular from the apex. Right. Right. Now, students, here, how to draw a perpendicular from the apex? How to draw a perpendicular from the apex? Or not? No. Right. Students, I'm going to draw a perpendicular to the base from the apex. Right? Here. Right. This meet the base in 2 points. So we have to draw the two sectors from this point. Right. To keep this one and draw an arc. Then you have to keep it in this point in the same radius, right? I didn't change the radius. Right? Right. Now what happened? If you join these two lines, right? This is perpendicular, right? The bisector of the angle, student, same. You have to draw an arc, then bisect. Then if you join, this is the angular bisector. The straight line joining the apex, you have to find out the midpoint and join. Then perpendicular bisector of the straight line. Student, you have to draw the perpendicular bisector using the compass. Draw an arc, another arc. Keep it in this point, right? You move the center as this point, then draw an arc. Then what happens? If you join it, this one perpendicular line also passes through. So here, in an isosceles triangle, the perpendicular drawn from the apex to the opposite side, the bisector of the apex angle, the straight line joining the apex to the midpoint of the opposite side, the perpendicular bisector of the side opposite to the apex are same. All are same. Okay, this is very important conclusion. Right. Okay, now we can go to the parallelograms. Student, what is the definition of parallelogram? Here, the definition is given. Student, definition different, properties different. Okay. Why, student, this is parallelogram? In a quadrilateral, opposite sides are parallel. It is a parallelogram. Right. A quadrilateral with both pairs of opposite sides parallel, it is defined as a parallelogram. Right? In a quadrilateral, students, opposite sides parallel. Then there is a parallelogram. Okay. Now, these are properties of parallelogram. These are properties of parallelogram. In a parallelogram, opposite sides are equal, opposite angles are equal. The area of the parallelogram is bisected by the diagonal. In a parallelogram, diagonal bisect each other. Okay, these are the properties. So if you want to prove that there is a parallelogram, you have to mention opposite sides are parallel, so there is a parallelogram. Right? Okay. But students, here inverse theorem also there. In a quadrilateral, opposite sides are equal, there is a parallelogram. Opposite angles are equal, it is a parallelogram. Diagonal bisect each other, it is a parallelogram. These are the converse theorem also there. Right. Okay. The how to prove that, students? Here in this parallelogram. So opposite sides are parallel. We just connect to the point B and D in this triangle. In the triangles ABD, CBD, students, this angle equal to this angle, alternate angle, this angle equal to this angle. So shall I mention it theta? Theta equal to theta, beta equal to beta. Okay. Now, students, the DB is common side in these two triangles. So two triangles are congruent. These two triangles are congruent according to the case, angle side. So if the two triangles are congruent, corresponding elements are equal. AB equal to DC and AD equal to BC. Okay, first you have to prove these two triangles are congruent. Then you prove corresponding elements are equal. So opposite angles equal, we prove. Then if this A, this one also A, corresponding elements of congruent triangles. Then this is theta plus beta, this one also theta plus beta, so opposite angles also equal. A equal A, theta plus beta equal to theta plus beta, so other opposite angles also equal. Students, if these two triangles are congruent, then area also equal. The congruent triangles, all properties are equal. Area equal area, perimeter equal perimeter, everything. Right. So we have to prove the other, we have to draw the other diagonal, then we can prove these diagonals also bisect the two triangles. Right. Then, okay, now the theorem 2 in this parallelogram. What do you mean? The theorem, the provement, we can use the axiom and the previous provement. We have to build another relationship. Okay, here already we proved this side equal to this side. We proved in the theorem 1. This angle equal to this angle, vertically opposite angle. This angle equal to this angle, alternate angle. So these two triangles are congruent. If these two triangles are congruent, this side equal to this side equal to this. What can you say about these two? Okay, so diagonal bisect each other. So this is the formal theorem for this problem. Okay, right. Right, next. Okay, students, in this quadrilateral, in a quadrilateral, opposite sides are equal, it is a parallelogram. In a quadrilateral, opposite sides are equal, it is a parallelogram. In a quadrilateral, opposite angles are equal, it is a parallelogram. Then, in a quadrilateral, diagonal bisect each other, it is a parallelogram. In a quadrilateral, diagonal bisect each other, it is a parallelogram. In a quadrilateral, very important, in a quadrilateral, the same pair of opposite sides equal and parallel. Same pair of opposite sides equal and parallel, it is a parallelogram. Okay, the 4 conditions, students. One more time. In a quadrilateral, opposite sides are equal, then that is a parallelogram. Opposite angles equal, that is a parallelogram. Diagonal bisect each other, there is a parallelogram. Same pair of opposite sides equal and parallel, it is a parallelogram. So students, you have to do the one of the exercise in your textbook. Find out there is a parallelogram or not. Right. Yeah, there's your some of the questions in your grade 10 textbook. Right. From the following quadrilaterals, select ones which can be concluded to be parallelograms based on the given information. Take the first one. A. A is a parallelogram or not? A. This side is parallel. This side is equal. Student, very important thing. The condition, same pair of parallel lines equal and parallel. Here, this is different. Here, one pair equal, another pair parallel. So that is not a parallelogram. This one is equal, opposite sides equal. This opposite sides equal, there is a parallelogram. Here, students, opposite angles are not equal. So that is not a parallelogram. Opposite sides equal. All sides are equal. That is the additional one, special one. But here opposite sides are equal, so parallel. According to the data, we can't, students, the data are not enough. This side is equal. One of the angles here. So that is not a parallelogram. Data is not enough. Here diagonal bisect each other, parallelogram. In G, opposite sides are, one pair is equal, one pair is parallel. Not a parallelogram. Here, adjacent sides are equal. So that is not a parallelogram. Okay, A is not a parallelogram, B is parallelogram, C is not, D is parallelogram, E is not a parallelogram, F is parallelogram, G not a parallelogram, H not a parallelogram. Right, next. Right, check. Here students, two angles are equal, but opposite angles are not equal. That is not a parallelogram. Here diagonal bisect each other. All are equal, but diagonal bisect each other. That satisfies that condition. So parallelogram. Here same pair of parallel lines equal and parallel. So parallelogram. Here diagonals are not bisected. Here this side, two sides are equal. These are equal. So that is not a parallelogram. Here opposite angles equal. Opposite angles equal. So that is a parallelogram. Here, according to the sum of interior angle of a quadrilateral, sum of interior angle of a quadrilateral 360 degree. Here 60, 120, 60, 180, 240. So this one is 120. Opposite angles equal, parallelogram. 100, 100, okay, 75, 275. So what is the remaining angle? 85, right? Sorry. How much? 360 minus 275. 5. This is, yeah, 85. This is not equal, so that is not a parallel. Here, student, these two sides are equal, but corresponding alternate angles are not equal. So that is not parallel, so not a parallelogram. Right. Now, students, this one 110, 60, not a parallelogram. The data are not enough. 80, 100, so 180. These are parallel. Sum of allied angle is 180. So these are parallel, so parallelogram. Here, this side are equal, but according to this, consider the alternate angle, this side parallel. But one pair of opposite side equal, another pair is parallel, so that is not a parallel. According to this is not a parallel, right? Okay. Now, special properties of parallelogram. Right. Okay. What do you mean rectangle? What is the least condition that parallelogram to be a rectangle? What is the least condition? That parallelogram to be a rectangle. Anybody? In a parallelogram, only one angle is right angle, opposite angle right angle. Parallel line 90 degree, 90 degree. So that will be a parallelogram. So in a parallelogram, sorry, that will be a rectangle. In a parallelogram, only one angle is right angle. Then that is a rectangle. What are the special features in a rectangle? All the vertices angle right angle, 90, 90, 90. All the diagonal lengths are equal. SQ equal to PR. Very important thing. You can apply in the theorems. Okay, right. Next square. In which condition that parallelogram to be a square, students adjacent side equal and one angle right angle. Adjacent side equal, if these two sides equal, the x, this one also x, this one x. So that is a rhombus. But if you mention one angle is right angle, right angle, right angle, right angle, right angle. So that is a square. Okay. Now, student, what are the special properties of square? Diagonals are equal in length. All sides are equal in length. Then diagonals equal in length. One more thing, diagonal bisect each other, angle right angle. Here, diagonals bisect each other at right angle. Very important thing. In another quadrilateral also, the diagonal bisect each other at right angle. What is that quadrilateral? That is a rhombus. Right? Okay. Now, the angles here, the angles are bisected by the diagonal 45, 45, 45, 45, 45, 45, 45, 45. Right. These are the case. Right. Next. For diagonals equal in rectangle and square. Next. Students, in a parallelogram, two adjacent sides are equal. In a parallelogram, two adjacent sides are equal. That is a rhombus. Okay. That is the least condition. If the adjacent sides are equal, that is a which one? Rhombus. Right. Now, when two adjacent sides of a parallelogram, right? Okay. What are the special case, special conditions, properties in a rhombus? What are the special properties of a rhombus? All sides are equal. Diagonal bisect each other at right angle. Bisected by the angles. The angles are bisected by the diagonals. Here, all the sides are equal. The diagonal bisect each other angle, right angle. Diagonal at the vertices are bisected by the diagonal. Angles at the vertices are bisected by the diagonal. That means, students, x, x. Opposite angles are equal, x, x. Y, 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 y. Okay, these are the properties of the special parallelogram. Special parallelograms are rectangle, square, rhombus. Right. We can move to the next. Yeah. Circular theorems. Chord of a circle. Students, can you identify these parts of the circle? Okay, these are the basic thing. This is center. This one is radius. Okay. This one is chord. Okay, this is circumference. One more time. The intersection point of axis of symmetry of a circle is center. The straight line joining the center and a point on a circle is called radius. The straight line joining any 2 points on a circle is called chord. If the chord is passes through center, that is diameter. Students, the longest chord is diameter. Then the diameter is 2 times of radius. Okay, these are the facts about the parts of the circle. Right. Next. Okay, the theorem. Students, one more thing. Well, some of the students are not in the group. Yeah, I can put the geometry worksheet for you. If you are not in the group, if you're not in the group, I can send the common group link, students. Maths Plus. If you are not in the group, if you join, then I can give uh, some of the other materials related to geometry. Right. Right. Students, one of the link is there in the chat box. If you need the other materials, right, soft copies, then you can join this group. Then I can put the geometry related geometry materials in this group, right? Have you got it? Anybody in waiting room? Oh, one more time. Right. Right. Students, some of the other worksheets are there. So I can put the geometric worksheet in that group, right? Right. Okay. Theorem, the straight line joining the center of the circle to the midpoint of the chord is perpendicular to the chord. Students, this is a chord, this is the center, this is the midpoint. Then what happened? This is perpendicular. That is the theorem. Okay. So, okay, we can prove. Here, consider these two triangles. No, this is AB is the chord, X is the midpoint. A construction, we connect OA and OB. OA, ONA, ONB. Now these two are triangles. Here, this side equal to this side. This side equal to this side. That means OA equal to OB radii. AX equal to BX given. OX equal to OX common. In the triangles OAX, OBX, OA equal to OB, the reason radii, then OX equal to OX, common side, then AX equal to BX given. Therefore, triangle OAX congruent to triangle OBX, side, side, side. If the two triangles are congruent, OXA angle equal to OXB angle. Corresponding elements of congruent triangles. But OXA plus OXB 180 degree, all are same, student, all are equal. So 2 times OXA equal to 180 degree. So OXA equal to how much? 90 degree. If that one of the angle is 90 degrees, this is perpendicular. This is the formal provement of the theorem. Okay, have you understood? Formal of the provement of the theorem. Right, next. The perpendicular drawn from the center to a circle to the chord bisect the chord. Okay, this is perpendicular, students. Then we can prove PR equal to RQ. How to prove the same? Join. In these two triangles, this is right angle triangle, hypotenuse equal to hypotenuse. OR, one of the side are equal. So what can you say about these two triangles? Two triangles are congruent of the case RHS. What is the case? RHS. PR equal to, these two triangles are congruent. So according to the congruency, PR is equal to RQ, corresponding elements of congruent triangles. Corresponding elements of congruent. Then the provement done. Okay. So the perpendicular drawn from the center to a circle to a chord bisect the chord. Right, next. Right, very important, students, very important theorems. So related to angles in a circle. Okay, can you verify major arc, minor arc? Student, this one is major arc. Right, the red color one is major arc. Now the red color one is minor arc. Okay, major arc, minor arc. Okay. Next. Okay. Yes, student. What is this AB? The minor arc AB subtend angle at the center. Theta. The minor arc AB subtend angle at the center. This one, the major arc AB subtend angle at the center. Theta. One more time. The minor arc AB subtend angle at the center. Major arc AB subtend angle at the center. Can you identify these two diagrams? Right, now theorem. One more thing. Here, student, the minor arc, this is arc. In this circle, this is arc. We mentioned this one. So this is the remaining part of the arc. So the minor arc, subtend angle, the remaining part of the circle. Is the minor arc, subtend angle at the remaining part of the circle. The second diagram, this is major arc. Major arc subtend angle at the remaining part of the circle. Okay, right. Right, here some of the diagrams, students. If you understand minor arc, major arc, subtended angle at the center, subtended angle at the remaining part of the circle, you can answer this question. Okay, I can give 2 minutes time. Then understand how to connect the, how to construct the angles according to the diagram, according to the given data. Okay, time over. You need the geometry, please. Have you got it? Right. Right. An angle that is subtended on the remaining part of the circle by the minor arc in the figure A. Okay. So minor arc AB, uh, A, O, sorry, remaining part of the circle. The angle that is subtended on the remaining part of the circle by the minor arc. So minor arc subtend angle at the remaining part of the circle. The angle is subtended by the center by the minor arc. Minor arc subtended angle at the center. The angle that is subtended on the remaining part of the circle by the major arc. Students, the major arc subtended angle is at the remaining part of the circle. Here, major arc. Then major arc subtended angle at the center. All of you check one more time. Here, this is the dark subtended angle at the remaining part of the circle. This is the minor arc subtended angle at the center of the circle. This is the major arc subtended angle at the remaining part of the circle. The major arc subtended angle at the center of the circle. Any doubts? Right. Now we can go to the next thing. Okay. The angle subtended at the arc at the center of the circle is twice the angle subtended by the same arc on the remaining part of the circle. This is very important theorem. Here, the arc AB subtended angle at the center. This is angle at the circumference. If this x, this one is 2x. Okay. Then this arc, if you consider the major arc subtended angle at the remaining part is y. This is center is 2y. So we have to prove that, right? The formal provement for this theorem. Students, these two sides are equal. If the angle is A, this one is A. What is the reason? These are radius equal, opposite angles of equal sides, A. Now, in this A, this is A. If you produce a side, this is 2A. The exterior angle is equal to sum of interior opposite angle, 2A. If this B, this one is B. So what can you say about this one? 2B. Right? Totally, this one is A plus B. What can you say about this one? 2A plus 2B. If you take out 2, A plus. Okay, students. So this is 2 times. So the arc subtended angle at the center is twice the angle subtended in the remaining part of the circle. Right? The same thing. Students, here, if this y, this one also y. So this one is 2y. Same thing, if this x, this one is x, this one is 2x. So this angle C is x plus y. This reflects the angle A or B, 2x plus 2y. If you take out 2, x plus 1. Right? So the arc subtended angle at the center of the circle is twice the angle subtended in the remaining part of the circle. This is the formal proof. Right? Okay. So next. Right? One more thing. The relationship between the angles in the same segment. Relationship between the angles in the same segment. This is major segment. The shaded one is major segment. The dotted one is minor segment. Okay, major segment, minor segment. It is okay? Right. Next. Major segment, minor segment. Okay. So next theorem, students, the angles in the same segment of the circle are equal. What is? The angles in the same segment of the circle are equal. Right. Here one of the construction, take this point as O, center as O. Students, if this x, this is 2x. If this 2x, this one is x, this one is x. If this 2x, this one is x. So what can you say about x? X, 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 all are equal. Okay, students. So the theorem is a segment. Same segment angles are equal. Same segment angles are equal. Right, next. Right, angles in the semicircle. Angles in the semicircle. Students, this is semicircle. This is other part of the circle. So here, this one subtended angle at the semicircle. Here, angles in the semicircle. Angles in the semicircle. Okay, right. We can check the theorem, students. An angle in the semicircle is right angle. Angle in the semicircle is right angle. That is easy proven. Students, this arc subtended angle at the center is how much? 180 degrees. This is 180 degree. This one is how much? 90 degree. This is 180 degrees. This is 90 degrees. It is okay. This is 180 degree. This is 90 degree. Right. Now, students, some of the question. We learned this one now. Right. These are some of the worksheet for the geometry, grade 10 geometry. Okay. So, right, this question. Friends, all of you send your answer. I can put this paper in the group, students, so no problem. So you just answer for this question. Okay, if you know the answer, send your answer in the chat box. We need X and A. We need the answer for X and Y. Students, if you finish, send your answer in the chat box. Students, we finished the theorems and the basic thing in grade 10 syllabus. Okay. Now we can discuss the question. So if you know the answer, send your answer in the chat. I need both answers, A and X. Okay, Darren send the answer. Right. Darren. Pajivan send the answer. Karsha send the answer. Karsha, I need the both. Okay. Divyesh, okay. All right, Karsha, your answer, okay. Mugilan send the answer, okay. Tanya send the answer, okay. Yusuf, Kamsavarshini, then Vedika, Nihensa, Manuka, Aisha, Ammar, C. Avinia. Send the answers. Right, students. Okay, your time over. Students, if this 100, this one is 100, what is the reason, students? Corresponding angle. These are corresponding angle. Here, students, 70 degree A. So, if you produce a side of the triangle, the exterior angle formed. The exterior angle is equal to interior opposite angle. So, A plus 70 equal to 100. A equal to 30. It is okay? Right. Right. That one is okay. Next question. Right. Next. Students, how much X and Y? That is easy. Easy for you. Right. Okay, students, that is easy. All sides are equal. So this is 60. 60 degree. If this 60 degree, this one is 60 degree. So X is 180 minus 60. How much? 120 degree. Okay. These are 60, right? Okay. The most of the students send you answers. Right. Lot of messages are there, then I can't open. Right. Students, next. Right. Next question. Hmm. Right. Next question. How much X, how much Y? Right. Students, what is the answer for this question? Right. I think the time is enough, right? Okay, for you. Right. This is 10, this is 30 students. We can find out this one. How much? 10, 30, this is 40 degrees. If this 40, these are parallel. So this is 40 degrees. Okay. 40, 70. 40, 70. 40, 70. So 110. So this is 70. If this 70, this one is 70. Is okay? Right. Next. Right. I need this one. Right. Friends, I need the answer for this question. BCD how much, right? Only answers. Students, I need the answer BCD, right? Okay, sir, given. Okay, Medana. Okay, Darun. Sudiksha, why? Okay, Jania. Sudiksha, check your answer. Yeah. Okay, Manoga. Monica, Monica, check your answer. Darunika, check your answer. The Avinia, no, that is the previous answer. Sandosi, okay. Yusuf, okay, Yusuf. Vedika, okay. Theo, no. Akshara, check your answer. Okay, Aisha, okay. Niansa, okay. Niansa, okay. Amar, no. Amar, check. No. Sudiksha, no. Monica. Darunika, okay. Darunika, okay. Seon, okay. The Avinia, okay. Seon, okay. Right, okay, students. Right, this one, AB equal to S. AB equal to S. Right? Okay. So these two sides are equal. Then students, EC, EC equal to ED. This side equal. If this 35, this one is 35. Okay. Right. This is 35. This one is 35. Now, student, this one is 70 degree. It is okay. This one is 70 degree. This one 70 degree. This one is 70 degree. Okay. But student, this is 70 degree. These two sides are equal. 180 minus 70, that is 110. 110 divide by 2 is 55. 55. Right. They ask BCD, this total 55 plus 35. So 90 degree. Next, students, check this answer. Hmm. Right. Right. Answer this one, students. X. I need X. I need the value for X. Can you answer in the chat box? Hmm. Sajeevan send the answer. Oh, Tanya send the answer, but Sajeevan answer, Tanya answers are different. 2 degree different. Darun send the answer. Okay, Darun, Sajeevan answers are correct. Same. Sandoshi answer also same. Manoga answer also same. Kamshavarshini answers also same. Aisha answer also same. Seon answer also the same. Mugilan same answer. Dharanika same answer. Sudiksa same answer. Amar check your answer. Avedika same answer. Medana same answer. Diveswar, you additionally put one. So I think your answer is correct. Akshara, okay. Hey, Akshaya, uh, check your answer. Okay, Tanya. Amar, check your answer. Harsha, okay. Right. Right, students? Right. Yusuf send the answer. Okay, Yusuf. Right, students, answer for this question. Here, this is 74 degrees. So this is 90 degrees. We can find out this one. So how much? 90 minus 70. 10 minus 4, 6. 8 minus 7, 1. So 16 degrees. If this 16, this one is 60. Okay, right. This one is 32. If this 32, this one is 30, according to the sides, right? So this one, x is 180 minus 30, 148. Right? That is 148. Right now, questioning. Lot of questions are there. So we can go to circle, congruency, everything. Right? 89 question. What is the value of x? Right. Your answers? Hmm. Number x, how much? No, Amar. Tanya, where is x? We will check, right? Tanya, Akshara. Tanya, how much? Akshara, Tanya answers are different. Medana send the answer. Oh, different answer. Vedika and Tanya answers are same. Darun, oh, Darun answers are also the same. This is Rajivan. Different answers are here. Amshavarshini, oh, same answer. Aisha, oh, different answer. Seon, different answer. Seon. Mugilan, yeah. Diksha, 36. Students, the most of the students send 36, so we will check that is correct or wrong, right? Okay, right, students, listen. If these 144, these are subtended angle and this remaining part of the circle is 144. So this one is double of 144, 288. In this 288, what is the magnitude of this angle? 360 360 minus 288. This is 2. This is 15 minus 8, 7. We took 1, so 72. If this 70, this one is 72. If these 72 students, how much this one? 36 degree. Right? 36 degree. Right. So students, I can give this to I will put it in the groups. So if you are in any other groups, you can receive it. So no problem. Okay, I will do the second seminar for O-level grade 11 syllabus in another day. I will inform through the WhatsApp groups. Okay. If you are not in the group, students, you click the link, students. Students, if you are not in the group, click this link. One more question, students. Here, I put in the my right. Yeah, I put that question in the presentation here. One of the question that is also got it in your book. How to show that PRS is equal to RSX in this question. If you everything is clear in the theorems, you can easily to answer this question. In grade 10, all the theorems are clear. You can easily to answer this question. PSQ is the diameter of the larger circle and SQ is the diameter of the smaller circle. If RQ intersect the smaller circle at X, show that PRS equal to RSX. How many students got this answer? How many students you have the idea? Click the raise hand button. How many students you have that idea? Click the raise hand button. Right, Sudisha. Right. Student, easy. Student, this is right angle. The reason semicircular angle is right angle in the smaller circle. In the large circle, that one also right angle. Okay. So these two sides are parallel. We can prove the sum of allied angle is 180 degrees. So parallel. Oh, corresponding angles are equal. So two lines are parallel. So if this X, this one is X. Is okay? Right. That's all. Okay, student. Now I can finish this seminar. Students, next for the O-level student, grade, if this is grade 10 syllabus are finished, we can revise the O-level geometry syllabus in another class. Okay, students. Okay, bye. Have a nice day. Bye. God bless you. Bye.